All right, let's put it all together. Maybe this will be one big video. Maybe this will be two shorter ones. We'll find out. I don't know. I don't like to plan too much, as you can probably tell. So here's all of these gosh darn tests, and I have highlighted in blue here are 1, 2, 3, 4, 5, 6, 7, 8 different ways that we can test something to see if they're going to converge or not. And it's up to you to know which ones to use where. So let's see like an example of maybe like 8 problems that could be thrown onto an exam. There we go. There's 8 problems. And now we're going to play a game where we can only use each test once. Now, if we get stuck and we see that, well, I can solve 2 of them with the same method, well, there will be a small penalty. But I'd still rather you do the problems and show you can solve them. But the game is to get all your points. We're only going to use each test once. So let's just kind of list them here. I don't want to go through and do each one of them, but we have our geometric. We have an integral test. We have a comparison test. We have a limit comparison test. Oh, we have our divergence test. That's the one you always want to leave to last, because that's the simplest one to use. We have ratio. We have root. And then we have the alternating series test. Okay, now how are we going to figure out which ones are which? Well, the thing is, I want to play a game. I want to save this one. I want to save the divergence test for as long as possible. Because if I can find something that's divergent, I might be able to use another test to find out it's divergent. And divergence test is the simplest one. You just take the limit, and if it doesn't go to 0, it doesn't converge. So that's the simple one. So we want to wait on that as much as possible. So I start just looking through. I'm like, all right, there's just some K's. I'm going to skip this one. There's a factorial. I see a factorial. So I'm like, I'm going to guess this one's ratio. I'm going to guess. I don't know. Is it? Is it not? But I'll find out. Just kind of. So I have like all right, I think I have the ratio. Now I move on to number 3, and I'm like, oh, there's a -1 to the K. And then start looking through the rest of them. I'm like, there's no other -1s to the K. Oh, this has to be the alternating series test. There's no other way. So I think we have the alternating series test. So now we move. Please shut up, Siri. Please shut up. Now we go to number 4, and I'm like, I think I see it. I see a 3/4. I'm feeling geo, but I don't know. I'm feeling geo. You know what I mean? Because you got the 3/4. Yeah, that's got to be a geometric. There might be other ways of solving them, and some of these might have 2 or 3 different ways of doing them. I try and give you a little bit of leeway through it. Now we go to our next, and we're like, there's just a K and a 2K. I know the limit's going to go to 0, but how do I show it? I'm not sure. I think I'm going to look at everything else first. I'm going to keep looking. So I know that's not divergent. Or I'm not going to use a divergence test. Just because I know the limit, I'm pretty sure an exponential, 2 to the K, is going to grow faster than K. So I'm like, I'm pretty sure that's not divergent. So maybe I'll just wait. Maybe I'm just gonna wait and then look back. So I think we have 3 of them so far. Now we get to number 6, and I'm like, well, that looks like the integral of inverse tangent. So I'm going to think integral test. But I'm pretty sure there's something else you could do here. I don't know. I think I'll put it on the right-hand side because I'm not 100% sure. I get to number 7, and I'm like, what? I've seen this too many times. That's 1 + 1/K. That thing's going to diverge. You know what? I think I want to look at this one with a divergence test. And then, lastly, we get down to number 8. Okay, I think we got the divergence test. And I'm looking at my list and going, well, all we have left is the comparison test and the limit comparison test. And we weren't really sure on we weren't really sure on the integral test. I mean, I know it works, but I think there's another way of doing it. Now I look at this last one and I'm like, oh, I don't know. I don't know how to do a limit comparison test. There's no pluses or anything. There's no minuses. There's no comparison test. I'm not going to be able to make that thing bigger. So I'm like, dude, I think that's the integral test. But I've already used the integral test. Dang, so I know the integral test is done, but I think that's the integral test because it's like, right, integral 1 over x, ln squared of x dx. You make u ln of x. Du will be the 1 over x, and I get rid of that x down the bottom. So I know that's going to work with the integral test. Now I just got to decide, and then I'm like, well, shoot, what's left? We have a comparison test, and we have a limit comparison test. Which one should we use? Oh, we could do a comparison on number 6. Look at this. 1 over k squared plus 1. Well, that's smaller than 1 over k squared. Hey, I think that's going to work. That's a direct comparison. So, I think maybe the comparison test will work on this one. Cool. So I have the integral test over here, and I have the comparison test. So process of elimination tells me I think this will be the limit comparison test. And that would work perfectly. You got pluses and minuses where we could compare it to k over k squared, and then maybe something will pop out from it. Let's go. I like it. I think we have an idea. So I get rid of all this, and I'm like, I think I have a game plan. Now, make plans, see what happens. You make plans. Whoo! Isn't there like some sort of term? I'm not really a religious guy or anything like that. It's like, you want to make God laugh, make plans. You know? So, best laid plans. Might not work, but I think it will. I think it will. Oh, I didn't cross off root. Root. Oh, because we never did root. Oh man, I forgot to look at number 5. I think this would be good if it had a root k on top of it. I think that would work great. Sorry about that. I just didn't even see it. Dang. But hey, I think it's worked out okay. So I think that one's probably going to be root. Sorry about that. I see that 2 to the power of k. Anytime you see the power of k, there's no factorials or anything. I don't know. There's nothing else with the power of k on it. So that's telling me I'm just alerting my eyes to roots. Root. Because we're going to use a root k. Now once we're here, I think we're just going to go for it. I think we're just going for it. I'm going to make one long video. You can pause it. You can go do something else. So let's see if this is going to work. So number 1. We're like, all right. So, oh, shoot. That's the limit. Come on, man. So we're going to want to take our k plus 3 and our k squared plus 5 and go, that's kind of like k over k squared. 1 over k. So the limit comparison test will tell us, what does the limit comparison test tell us again? Oh, so if you can supply some b sub k, and we find out that the limit of that a sub k over the b sub k is greater than 0, oh, it's going to diverge wherever the b sub k diverges, and it will converge wherever the b sub k converges. That's how it goes. All right, good deal. Let's run it. Let's go back. We're like, okay, so let's call this one a sub k, one we had. And then we're going to call our other one our or b sub k. Sorry about that. I get them backwards. There's so many of these. And our test, limit comparison test, tells us that whatever happens to our b sub k, you know, the sum is k is equal to, where do we start? 3. Up to infinity of 1 over k. Well, we know that diverges because it's a telescoping series. So if we can find that, what is it again? Oh, if we can find out that the limit is greater than or equal to 0, and our first one converges. Oh, it doesn't. It diverges. Oh, so we look at here and we're like, the conditions for divergence means, well, as long as we can get some sort of positive number out of this bad boy, it's also going to diverge. So let's see what we get. So we're going to take it and go, all right, let's take the limit as k goes to infinity of our a sub k over our b sub k. So that's the limit as k goes to infinity, and I'm going to speed up. And then we're going to divide by 1 over k. Get the frick up out of here. You mean divide by 1 over k is the same thing as multiplying by k? Let's bring that stuff in. Let's see what we get. And we got the limit as k goes to infinity. That's k squared plus 3k over k squared plus 5. All we care about is the leading coefficients. So this is 1 over 1, which is equal to 1. And 1 is most certainly greater than 0. Therefore, since b sub k diverged, the sum is k is equal to 3 up to infinity of k plus 3 over k plus 5 diverges by the limit comparison test. There's number 1. LCT worked. That makes me feel really good about the comparison test and everything else that we got. Let's move now to our ratio. Remember how we found our ratio? We looked and we're like, hey, there's a little exclamation point in this bad boy. Let's see if that works out. So we have k raised to the power of k over 2k raised, or factorial here. So I think what I'm going to do is I'm just going to finish up number 2, and I'll come back and we'll do 3, 4, 5, 6, 7, and 8 in another video. It's just a little too long, and I'll be making half-hour videos and making my stuff all screwed up. So we thought ratio, right? So this was our thought. Ratio. Because there's that exclamation point. So we're like, all right, well, let's come up with some a sub k plus 1. That's our a sub k right inside of here. That's your a sub k. So we're just going to say that's k plus 1 raised to the power of k plus 1 all over 2 times k plus 1. Uh-oh. This might get a little weird. And then we got our a sub k, which is k to the k over 2k. Factorial. Okey doke. Let's get this thing. So we're going to take our limit as k goes towards infinity of our a sub k plus 1. So that's k plus 1 to the k plus 1. Do you get that? That's the same thing as up here. Just writing it down, like figuring it out. Might as well. And then we have our 2k plus 2 factorial. Just brought the 2 into both. And now we're going to multiply it by 2k factorial over k to the k. What could we do here? Oh, what do we do? Well, here comes the weird. Let's take 2k plus 2 factorial and see what the heck this turns out to be. I'm going to need to do a little bit of work here. So when k is equal to 1, you're going to get 2 times 1 plus 2, which is 4. When k is equal to 2, we're going to get 2 times 2 plus 2, which is equal to 6. And we get 3, we get 2 times 3 plus 2, which is equal to 8. And then what's the k minus 1th term? That's 2 times k minus 1 plus 2. What is that? What is that? That's 2k minus 2 plus 2. Oh, it's just 2k. And then what's the kth term? Well, it's given to you as 2k plus 2, which is 2 times our k plus 1, or just 2k plus 2. All right. Well, let's write this thing out. Let's write this out. So we got these 2 different factorials. So it's like, all right, so this is the limit as k is tending towards infinity. We got our k plus 1 over k. And I want to bring this k to the k over here. Put them next to each other since they have the same power. Oh, look, something might pop out of there. And then we're left with, we still got our k plus 1 up here, but that's not what we're worried about. We're worried about our 2k factorial. So let's start with 1. That's going to be 2, right? And then you're going to have times the next one is 2, so that's 4, and then we're going to have 6, and then we're going to have dot, 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 all the way up to 2 times k minus 1 times 2 to the k. Now we're going to deal with that 2k plus 2 to the power. So we're going to end up with a 4, a 6, an 8, a dot, dot, dot. And now we're going to go up to our k minus 1, which was just 2k. And then we're going to get our 2 times k plus 1. Yeah, that's going to work. That's going to work. Do you see that these are going to cancel? The 4, the 4, the 6, the 6, the 8, the 8. Oh, it looks like this is just one term ahead. This would actually cancel with what's back behind. So you wanted to take calculus, huh? All right. Sorry I signed you up for the class. I know this stuff is tough, dude. I know it's tough. Times k plus 1. We still have that 2 that's up here. And then we're left with 2 over k plus 1. Oh, look at that! Whack, 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 whack. All gone. The only thing we are left with is the limit is k tends towards infinity of k plus 1 over k raised to the power of k, which is equal to e. Which is equal to the limit is k tends towards infinity of 1 plus 1 over k raised to the k, which is exactly the definition of e. E is larger than 1, therefore, this diverges by the ratio test. And there we go. So we did the first two, 17 frickin' minutes in. So we knocked out the first two. So far, everything's worked out okay. Trying to recognize which one's which. Next, we're going to go into 3 through 8. And we'll knock those out. Sorry for such a long video, but shoot, I can't get anything done in frickin' 10 minutes in these long classes. Or these long topics. So, all right. I will see you in the next video to do the rest.